Okay. So account abstraction. Who here has heard of account abstraction before? Who here has an account? Who here has a smart contract account? Who here feels safer with a smart contract account? Who here feels that their life has been more convenient with a smart contract account? Okay, let's getting there, but I'm using definitely thanks to Lane for a pioneering use of technology, but I hope that in 2 years' time this will be half the room. So why account abstraction originally, right? So this is a topic I've really been talking about for over 10 years now. I remember even before Ethereum started, back at the end of 2013, I published this article on Bitcoin Magazine where I was basically shilling multi-sig wallets and arguing that we should move over to multi-sig wallets being the default kind of wallet that everyone has. And the goal basically is that Ethereum has a big, and crypto in general has a big security problem, right? So by default, there's basically two ways to use crypto. One way is you hold your keys in your own wallet that is controlled by your own private key. And if you lose that private key, you're screwed. Your retirement savings are screwed. If your private key gets taken by someone else, then you're also screwed. They're not screwed, but they're going to be happy, but you're screwed, right? So who here feels safe entrusting their life savings to a piece of 12 words on a paper? Okay, so who here feels safe entrusting their life savings to a 32 bytes in a piece of digital memory on their laptop or their phone? Okay, exactly 0 people, so that's good. So basically, and then the other approach to having your coins is, you just store them on Coinbase or store them on Binance or store them on a platform with a trustworthy, charismatic founder who takes pictures together with people like Bill Clinton, and then, you discover 2 years later that, the money's not there. So basically, we have, a version of decentralization that does not work for people, and we have a version of centralization that is not what the space is about, and that also does not work for people. And so the question is, can we find something sane in the middle, right? And, the idea of multi-sig wallets is basically you have multiple keys, right? You control one of the keys, and then maybe you have one key on your laptop, maybe one key on your phone, or maybe you control one key, and then some institution controls a second key, or maybe your friends control a second key, or maybe there's 3 keys, one on your computer, one that's the 12-word passphrase, and one that's held by some institution, and you need 2 of them to sign transactions. And so somehow use multiple keys and avoid having any one single point of failure, right? So I do this to store basically almost all of my funds. This is, I think these days generally considered to be the safest way to store large amounts of money. But the problem is that using these kinds of wallets is not efficient enough, right? So the way that Ethereum was originally constructed, unfortunately, is that even though you have this amazing property where the applications can have arbitrary code, the accounts that transactions start from cannot, right? The accounts that transactions start from, which are called externally owned accounts, those accounts can only be controlled by a single private key. And so if they're controlled by a single private key, then, there's basically no way to give them this extra level of security. And if you want to store your funds in a smart contract, then you can, but you have to go through extra hoops, right? You have to have this extra account that stores extra funds, and then you send your transaction through that account and then into the multi-sig, and it just gets needlessly complicated, right? So the early account abstraction proposals, particularly EIP 86, were basically attempts to try to solve this problem, right? And basically say, just like applications in Ethereum can have whatever code you want protecting the account and its assets. Accounts that users use can also have arbitrary validation code that defines the rules for how you use the wallet can approve transactions. EIP86 ended up having a lot of flaws. A later proposal called EIP208 also ended up having flaws. Also, the scope started expanding. EIP 2938, which was around 2019, was the first sort of full account abstraction proposal that really tried to take all the issues into account and really tried to be like a fully specified thing that you could put into Ethereum. But one of the challenges with that is that at the same time, we were doing the merge and basically trying really hard to switch over to proof of stake. And so there was just not much core developer bandwidth to worry about it, right? And so instead, a decision was made to focus initial account abstraction work off-chain and or rather outside the core protocol using this ERC called ERC 4337 that wallets and users could independently participate in. At the same time, there was also interest in ERC 3074 and various work on what's called sponsored transactions, where other people would pay transaction fees for you, which could also allow you to pay transaction fees using ERC20s other than ETH. And a lot of those work streams really ended up merging, right? So this is probably the most important slide here. This is modern account abstraction, right? Modern account abstraction is this really interesting coalition that combines together a whole bunch of different goals that are, and like basically this is what ideal account abstraction would all cover, right? And this includes both security goals and it includes convenience goals, right? So let's just like quickly go through some of these, right? So wallets secured by trusted platform modules, such as passkeys, right? So recently, phones and laptops and just user computing hardware in general there has been this growing trend of creating these trusted modules that are kind of walled off from the rest of the computer, that have much simpler code, much simpler logic inside of them, and a lot of like sensitive encryption and signing and holding secret data and other kinds of tasks happen inside of these modules. The goal of this is to increase security so that even if the outside computer gets hacked, even that kind of hack would still not be able to extract a key from inside of a TPM. And so keys would have this extra level of security. It would be amazing if users' wallets could also take advantage of this, right? But the challenge is that most TPMs, they don't support the same elliptic curve that Bitcoin and Ethereum use. Bitcoin and Ethereum uses SEC P256K1, TPMs use SEC P256R1. But if we had account abstraction, then account abstraction would basically let you implement a SEC P256R1 verifier as a piece of code and then use that as your account. Now, there are some, I have some color coding here, right? So not doable with MPC, not doable with 3074, and not doable with both. Basically, there are some other technologies that can provide like some of this functionality, right? So EIP, right, that should be EIP 3074, not ERC. It is kind of like a solution to a partial set of these problems. Like it definitely explicitly, I think, focuses more on the convenience goals than on some of the pure security goals, right? And I think even the developers of it, right, acknowledge that the goal is not to solve the security problems on the left, and eventually we do need something that solves all of the problems, right? So there's different categories of problems and different categories of tasks here, right? And then MPC, so using cryptography, multi-party computation to try to distribute up a key between different places, it also ends up not actually being able to solve for this use case. Basically, MPC is much weaker than smart contracts because it has a lot of these internal limitations to what kind of logic it's capable of processing. And TPMs are one of the things that, in this case, it cannot do because, you can't turn an ECDSA problem into an ECDSA problem of a different curve, regardless of what cryptography you're using. account recovery, right? So this is basically, if you lose your account, other people should be able to help you recover your account. This one is actually kind of doable with other technologies, but full ideal account abstraction gives you a more general purpose way to do it. Multisig, so having an account that is, instead of being controlled by one person, gets controlled by some collection of keys that work together, right? So you could have like a 2 of 3, you could have a 4 of 6, the Ethereum Foundation wallet is a 4 of 7. This can also actually be done with other technologies. Allow changing and revoking keys, right? You have an account, your account is controlled by one key today, but let's say at some point you decide, wait, my computer might have been hacked, it might not have been, I'm not sure, but I want to switch over and have some different key control my account instead. This is also something that a lot of these kind of simpler technologies that try to preserve existing EOAs cannot really do, but account abstraction does. Quantum safe cryptography. So eventually, a lot of current cryptography is not safe against quantum computers, but a lot of newer cryptography is. And so switching to it, that also requires switching to some very different algorithms. Granular access control, so spending limits, right? So the Ethereum Foundation wallet does this. If you want to send a smaller amount, one person could do it. If you want to spend a very large amount, then you need 4 of 7 to do it. This also requires some programmatic logic. One of the reasons why I have it like half purple, half blue here is that if you're willing to trust an institutional cosigner, then you can technically do it with MPC, but we prefer, ideally we'd get a trust-free solution. Multiple operations in one transaction, right? So who here has had the experience of be it like going on Uniswap or CowSwap or whatever other swap, trying to swap a coin and then having to first approve and then wait 5 minutes and then send a second transaction? Who here would prefer to not have that experience? Okay, so this is also something that account abstraction accomplishes. 3074 also accomplishes it. Session keys, so being able to create subkeys for specific applications. This is very valuable for decentralized social, for example. Paying gas in ERC20 tokens. So let's say you are some user in, could be Turkey, could be Nigeria, could be Argentina, wherever else, and you you receive 50 USDC and you want to spend that USDC to buy food. Well, problem is you only have USDC. Ethereum only accepts ETH for paying gas. And so, you have to have some kind of system where you basically have a market where you can pay the USDC and other people can accept the USDC and pay the gas for you. You could do this with your 3074, though the solution there is definitely more dependent on centralized actors. With account abstraction, you can have a more full mempool for these kinds of things. Signature batch verification. So this is the idea that if you have 1,000 transactions with 1,000 signatures, you can combine them all into one with BLS aggregation or ZK snarks, and that combined signature becomes much easier to verify than the 1,000 of them separately. This is especially valuable on layer 2s, where on layer 2s, computation is cheap, but data is still expensive, and so there's a huge benefit to compressing data. Automation, so being able to pay per month, right? So this is a really nice one. So who here pays for monthly subscription services with their credit card? Who here would love to be able to do the same with crypto? Who here would love to be able to do the same with crypto without having to manually sign a transaction every month, but keep the ability in their hands to be able to cancel the subscription at any time? So you don't have to call 1-800 blah, blah, blah in order to cancel a subscription and go through 40-minute customer service. No, you say you stop paying and the corporation needs to notice that you stop paying and it's up to them to shut down the service, right? This is how things should work. But can we have that, in a way that actually does create this open ecosystem, doesn't depend on everyone coordinating around one centralized actor, right? Account abstraction can help. MPC with trusted institutional guardians, could also potentially do it. Basically, you could pre-sign and, the institution could do the monthly signing for you. Sponsored transactions, so basically being able to applications paying for transaction fees on behalf of users, and being able to parallelizable nonsense. So being able to send lots of transactions in parallel and have them get included in arbitrary orders, right? So there's a lot of security features here, right? And there's a lot of convenience features here. So who here wants their on-chain experience to be more secure? Who here wants their on-chain experience to be more convenient? Yeah. Who here wants both? Who here doesn't care much about either? Okay, so this is why account abstraction, right? There's a lot of things in this slide, and I acknowledge that I blasted you with a whole bunch of concepts, but there's a reason why this is a slide, right? And, there's a bunch of terms here, and I highly encourage everyone who doesn't fully understand to just go off on your own time and Google each and every one of these terms that you're interested in, understand ERC 3074, understand ERC 4337, RP 7560, and basically really kind of poke in, how account abstraction actually can give you a lot of these things that really are super valuable in helping you keep more of your own money and keep more of your own time. So this, I think, also feeds into an important broader context, which is that for the past 10 years, Ethereum has really been focusing a lot on improving the very kind of bottom level theoretical properties of the chain. So switching from proof of work to proof of stake, switching from being an L1-centric ecosystem to being an L2-centric ecosystem, and also Verkle trees. So Verkle trees already they're the next big thing after the blobs, and Verkle trees already have testnets. We have the blobs as of a few weeks ago. A bunch of rollups already got much cheaper. We have proof of stake as of already about 1.5 years. And, the Ethereum network's energy consumption has decreased by more than 99.9%. So a lot of very meaningful technical upgrades at the base layer have happened. But the next 10 years are going to be about really upgrading the ecosystem at the user level, right? And really upgrading the ecosystem from the perspective of, let's make something that people out there in the world, especially, people in lower income countries, just can actually go and use, right? And account abstraction is going to be a big part of this, right? And this includes making it easy for them to actually use, in the sense of just having them not be confused with really complicated UX to send a transaction. It also includes user experience of security. If you receive 50 USDC, and you're not good at technology, you should not just have a high risk every day of randomly losing it. So let us solve both of those problems. So we have basically, we value security, decentralization, openness. Users value convenience and low fees. We need to and we can provide both. So, concrete challenges with account abstraction, right? One is short-term functionality. Basically, this roadmap is something that is going to take quite a long time before it gets to everyone's wallet. You can try ERC 4337 wallets today, but they do have downsides, and users want short-term functionality on existing accounts, right? And so one of the largest pain points is batching, right? Being able to do things like approve an ERC20 and then spend within the same transaction. ERC 3074 and a big alternative, ERC 4806, are also both able to do this. Key challenge 2, cross-chain. Who here has assets on multiple chains, including layer 1, layer 2s of Ethereum, whatever else? Great. So one of the big questions is, do you use the same address across chains, or do you use different addresses, right? And this is still one of those where I think different groups are going in different directions, but my view is that I think we're increasingly going toward a different address on different chains world. And the reason basically is that eventually you're going to get to a chain that does not support the same cryptography that you support, right? And when you do, then your address on that chain is going to be different because you just have to use different cryptography to be on that chain. ERC 30 or 770 lets you have these addresses where the network is part of the address. And so if you give someone, ETH colon blah, 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 they're not going to be able to accidentally send you those coins on Optimism unless they do something horribly wrong. So this is one of those things that, like, in my opinion, needs to be kind of like standardized and accepted across the ecosystem more, but it still needs to make progress. A big one is also, how do you do recovery and key changes across chains, right? So if you decide you don't trust your current key anymore, you want to change your key, or you lose your key, you want your key recovered, how do you actually do that when you have assets on 20 different chains? Short-term solution, you just send 20 different recovery transactions on 20 chains. It's not perfect. It costs a lot of gas. You have to keep track of all the chains that you have assets on. But, it's easy to implement. It kind of works while it's starting to do it already. Longer term, there's this idea of key store contracts. Key store contracts, basically, they let you have a single place on one single L2 where you store the data that's related to your account, especially the keys and the algorithm that's needed to spend from it. And then you have a bunch of accounts on a bunch of different layer 2s that all point to it, right? And that pointer can actually be ZK'd, right? Like, basically, what happens is any transaction from any one of your accounts would have to make a ZK snark that proves the current key in your key store, and that also proves that you made a signature from that key. So the nice thing about this architecture is you can keep your key store and do your account management in one place, but then you automatically have your assets on every one of these L2s. Basically, anything where there are like trustless bridging mechanisms, and you can change your key store, do whatever once, and it immediately affects or very quickly affects all of your accounts. You also get privacy for free, which is very nice, right? Because if you use ZK snarks in this way, then basically by default, every address becomes a stealth address. So we get to improve on privacy, we get to improve on account management. This gets much easier if we standardize the ability for layer 2s to directly read the state of layer 1, but this is something that also is going to take some time. Smart contract wallet issues, right? So dApp developers, wallet developers really need to have their eyes open for this. Lots ERC 1271, off-chain signatures for smart contract wallets. Lots of wallets, lots of dApps do not support it yet. Gas costs of ERC 4337 need to go down. This is a protocol level problem. Inclusion lists, a feature that's being worked on and likely will be added soon to Ethereum to basically prevent centralized block builders from delaying when transactions get included, and basically discriminating between different applications. And that's a feature that we'll also have to support smart contract wallets. So a lot of technical stuff to work on. Also, I think the roadmap, right? So this is basically my diagram of a realistic way to get from here to there. Essentially, the question here is to think about both the short term and the long term, right? Short term, we basically have two different kinds of wallets today, right? We have externally owned accounts, and we have smart contract wallets that have much stronger security and functionality properties, but which are less efficient and which have worse UX, right? In the short term, we can do short-term extra EOA upgrades. And short-term EOA upgrades basically kind of lift up the functionality of EOAs to get to the point where we solve some basic user needs, like being able to do transaction batching, for example, right? Then, at the same time, we work on improved account abstraction EIPs. And this, I think, must include layer 1 stuff, right? 4337 was good for getting account abstraction out the door, but I think ultimately it does need to be converted to a layer 1 thing. And that needs to be, basically what happens is we do these EIPs to improve efficiency and compatibility of smart contract wallets. Then at the same time, we have other EIPs to improve some of the functionality of EOAs. And then both of those paths end up converging into smart contract wallets of tomorrow, right? So basically, within 2 to 4 years, the goal would be that an EOA with extra functionality would be equivalent to a very particular and very limited subset of of smart contract wallets that would become are possible today, but would become possible and convenient in the future, right? And so short-term, increase functionality, medium-term, increase the efficiency and composability of smart contract wallets, and do this in such a way that instead of creating two separate ecosystems that compete with each other, we're building toward one common ecosystem that shares infrastructure, right? So this is the really key thing. And once we're all in the smart contract wallet world, then things like upgrading accounts from one type to another becomes easier. So something like this, I think, is a possible goal. So conclusions, right? Account abstraction is shifting from research to production. For the first 5 years of account abstraction, probably for the first 7 years of account abstraction was theory. Basically, a lot of this very abstract discussion of what would an ideal account model look like. These days, it is a very real thing. There are lots of wallets that are creating smart contract wallets that you can go and use today. There is growing consensus on what the goals are, and there is growing consensus on an ideal final state for this whole ecosystem. And the main challenge is basically this very in the weeds, this very user level challenge of how do we gracefully move the existing ecosystem over to new and better approaches. And so big thank you to all the wallets who have been tirelessly working on this. Big thank you to all of the developers of, both ERC-4337 protocol developers and other account abstraction-related EIPs and ERCs, as well as everyone implementing anything on all the layers of the stack, and at the same time to anyone who has been helping to try and, actually use and battle test all of this technology in the forms in which it has existed so far. So this is a big work in progress, but I think for the sake of improving user experience and improving convenience or security, this is an extremely important one. And I hope to see a lot of progress in this area over the next few years. So thank you.
All right. Thank you for your presentation. So we are going to answer some questions. Come here. 아까 질문 주신 거 조금 발표를 좀 같이 볼게요. So do you want to scroll down? Do you want to scroll down and see if you want to answer any questions?
Okay.
It's not there, but...
Yeah. Okay, let's see. My favorite color is purple. Yeah, my favorite color is purple.
Really?
I think so. Okay, yeah, I'm just scrolling down. It's some people asking why Vitalik has not recognized their favorite projects. Some questions of why Vitalik has not recognized their favorite project. I think for multiple projects. Let's see. Yeah. Oh wow, people are asking me on AI safety. This is interesting. Yeah, okay, tomorrow we'll have a panel with, or a chat with Ilya on AI safety. Is quantum computing real? It is, it's definitely slowly becoming more real. Basically, yeah, it's, for a long time, quantum computing has been kind of a grift because, you'd have, there's what we talk about when we talk about quantum computers, which is computers that can break cryptography. And then there's quantum computers that D-Wave are selling, which are this much crappier thing called adiabatic quantum computers that they would try to push as being the same thing when they totally are not. But my impression is definitely that the state of quantum computing, real quantum computing technology, is slowly improving. And it's getting to the point where I don't know what the timelines are, but I think we definitely do need to act as a crypto ecosystem as though quantum computers really could come at any moment. So I view this as one of my areas of some pretty big uncertainty, and we just need to be prepared. What optimizations would I make for application-specific EVM chains? I think one thing that's underrated is if you're making an application-specific chain, it doesn't even necessarily need to be an EVM, right? What I think it needs to be is like take the logic of your application, turn that logic directly into a ZK circuit. Like there's increasingly good tools for doing that, and then just use that logic as your as the rules of your layer 2 directly, right? I think if you're building something for one application, then like that just feels like definitely the much better path to take, right? I think everyone having the EVM with 5 different applications on every side, like to me, it actually starts to feel less sense. Like I feel like either be the EVM or be something very specific, like really specific that really is what you need. What do I think about the metaverse? I mean, I think okay. So to me, yeah, like the metaverse is one of those things that's like very poorly defined, right? It's like a brand name more than a product. And it feels like everyone has this abstract idea that there is this like virtual universe that they can all participate and be part of, and that virtual universe is not actually owned by anyone and all of these things, right? But the challenge is like all of the, like it often gets connected with virtual reality, but then with virtual reality, the kinds of things that people actually need end up being much simpler, right? It's like, okay, like you basically want a laptop without the laptop, right? And that's like super useful, but that's like, it's not really averse. And so the thing that I expect is most similar to a metaverse that I think actually makes sense is like, it's not something that tries to be a metaverse, but something that just like takes all of the different virtual world things that we already have, including crypto parts, including virtual reality parts, including some AI parts, and combining them together in the right way. What's my take on EIP 3074? I think already answered, right? It solves a significant number of problems, but it's definitely far from like being a full solution that I would call ideal account abstraction. What do I think of FHE rollups? I think FHE rollups are, fully homomorphic encryption is super valuable for a bunch of applications. It does have very high overhead, so I think there's specific applications where it makes a huge amount of sense. Voting is, I think, a big one. I expect there to be others as well. Bridging and interop that are decentralized and require a trusted setup. I mean, my view on bridges is like I'm fairly bridge minimalist in the sense that like I believe in cross layer 2. And I believe in interchain. I do not believe in cross chain. And what I mean by this is that I think generally, like the nice thing about layer 2s is that the end game of layer 2s is that you actually have bridges that are fully trustless, right? Like if you have coins that are issued on Optimism, you can create a version of that coin on Arbitrum, and you can actually have a hard, unbreakable guarantee that if you have the Arbitrum coin, you can walk through the withdrawal mechanism and you can get your original Optimism coin back, right? And that is a hard, unbreakable guarantee that remains true even if Ethereum becomes 51% attacked, right? Like, I think that, like, really hard guarantee that you get from the fact that all Ethereum layer 2s are part of the same security domain and share Ethereum as their ultimate security guarantor and settlement layer is something that's really important. If we're talking about like going between ecosystems, like Ethereum and Bitcoin, for example, like if you have Bitcoin, like if you try to move Bitcoins onto Ethereum or, move Ethereum coins onto, Cardano or whatever else, then like you can, the problem is that like you are fundamentally trusting whatever that bridge is, right? And, you are vulnerable to, at the very least, 51% attacks of either one of those chains, right? And so if we start having huge amounts of people like issuing assets on one and then wrapping those assets and using those assets on another, that creates a more fragile and a more vulnerable ecosystem. And so what I favor instead is like keep your Ethereum assets on Ethereum, keep your Bitcoin assets on Bitcoin, keep your Monero assets on Monero, and then if you need, the way that we do interop is we have cross-chain atomic trading protocols to make it easier to move from one to the other, right? Like that's the version of interoperability that I'm personally more optimistic on. And then between layer twos, I think like for projects where because they all settle into Ethereum, you actually can have trustless interoperability between them. That's one where I think we really do need to accelerate and start like really moving toward that goal. If I don't do Ethereum, what would I do? So myself 10 years ago, I think the things that were in my mind before I decided going to crypto, one was machine learning. One was online education. I guess I still ended up, doing a blog. So, ended up doing online education anyway. Otherwise, I don't know. I mean, cat, yes, anonymous, some kind of weird math equation. Then anonymous, do I think fully homomorphic encryption is ideal for privacy? I think it's very ideal for some applications. I think it's overkill for some. Like, I think it's overkill for anything that involves moving coins around, because I think ZK snarks are sufficient for that. ZK snarks are sufficient for a lot of things, right? The problem with FHE is that it requires this, like, M of N trust assumption. But, so if you don't need that, then, like, if you don't need the extra properties that FHE has, then I think you should try to use ZK snarks. But there are definitely a lot of applications where ZK snarks by themselves are not good enough. And for those applications, then use FHE. One more. What's your take on native account abstraction chains? I mean, I think that stuff is cool. I think the one big plea that I want to give to people working on this stuff is, like, it make it compatible with the same final end goal, right? Like, there's no reason to not be compatible with, EIP 7560, for example, right? Like, I think we need this. The ecosystem gets stronger when we have compatibility, and ultimately, I think it gets much better if we are all using the same standard, so that it actually does become automatically possible by default for wallets to just be able to give you an account on every single one of these chains, right? So I think if you do that, then going native account abstraction early is, I think, absolutely awesome. So, thank you.